Hi Gabby. Most of the notes I've written on the paper here. First one. I would suggest that you probably use your calculator in your exam to work out these probabilities. I realise you've used the Z values, which is fine, but it just is more time consuming. And you may find if you put your calculator on statistics, 2, and then go to distribution F5, and then choose normal distribution F1, and then the second F2 key, you'll be able to put in lower values and upper values of where you want to find the probabilities. So I've marked on your paper just an example. The first one in A, the lower is 3.7, the upper, we don't have infinity, but we just put 9999. The mean is 4.2 and the standard deviation 0.55, and that gives the same probability as you calculated. It's just a lot faster. And the second one, we found the probability here is between 4.6 and 5.1 is the other limits, and the probability is 0.1826. I think you originally might have had that value, and we multiply it by 280, so that's 51 baby boys. The next one, we want the percentage less than 6 kilograms. So my lower limit is infinity, but we just put in minus 9999, and the upper limit is 6, and the probability there is 0.9995, or percentage 99 point, sorry, that should be 99.95 percentage they've asked for. You're right there. Just a little bit out. And going down the page, we're asked, that's right, you got the right answer there. On the calculator, instead of using the F2 key for the last key, we use the inverse normal key. So exit, so I go distribution, normal, and then the F3 key for inverse normal, and it asks me for the tail, is it the centre, the right or the left tail, and the area is 0.06, and then it will give me the X value here, just like you found. Next. In 1 month there were 29 baby boys in excess of 4.6 kilograms. So 4.6 is my lower, 999 is my upper. So the probability there is 0.2325. So if I have 29 babies out of X number of babies equals that probability, then X must be about 124 babies. And you calculated the interquartile fine, and as you said here, there was good arguments that you had about the using the range to know all babies, how all the boys' weight is spread, and includes the outliers, so that's good. The next, using the spinner, first one was right, the second one you got, oops, that right. Oh, okay, sorry, my page is moving funny. Yes, if Pam uses a spinner, what's the probability that a total of 2 spins was 7? The first spin she could get a 5, and then she could get a 2 on the second spin, but she could also get a 2 on the first spin and a 5 on the second spin. And likewise with 4 and 3, 4 on the first spin and 3 on the second, or she could get 3 on the first and 4 on the second. So you've got to actually double that probability that you've got there, so it'll actually be 1 in 8 is the chance of her getting a total of 7. And the next one, you actually ended up with the right answer here, but they obviously wanted you to show your method, so you worked out the probability of an odd number is 8 out of 12, and the probability of a 3 is 1 out of 12, so to find the relative probability, I guess it is, it's 1/12 divided by 8/12, which is probably how you found the 1/8, I would guess. Well done. Page was, these get a little bit trickier, don't they? That was well done. The first one, you did a nice tree there. Now the second one, it did take some working out. So we had a win, a loss or a draw, and at first glance the probability of that after 2 games Yvonne is winning, you would think that she'd need a win and a win, but they put in brackets here 3 or 4 points. Now 4 points was a win-win, but if she won the first one and drew the second one, then her opponent must have lost the first one and drawn the second one. So she would actually, even though she's only got 3 points, she'd have more than her opponent. So you do have to count in those games where she has, for example, won the first one and drawn the second one, because she would still be points ahead. Or if she draws the first one and wins the second one, that also makes her ahead on points. So you've got to add all of those points in. That's about it. This last one, I'm not so sure about this one off the top of my head. You've got Patrick wins. As a P, D is a draw. After 2 games, Patrick would be winning if he'd either won 2 games PP, or he'd won 1 and drawn 1, or he'd drawn 1 and won 1. So relatively speaking, if he draws, he could have a win and a draw, or a draw and a win, over the total probability of either being PP, a win and a draw, or a draw and a win. And I think you could probably take this further. If the probability of losing is P and the probability of winning is a Q, then probability of a draw is 1 take away your P and your Q added together. So you could probably work that into it as well. So I think that's all. Oh no, we had the salmon, but I think you did all of these really well. That one was fine. That was good, comparing the graphs. Alright, just one. That was your other answers there were fine. This one here, the relative risk. So we usually divide. So you found the risk of heart disease with no exercise and the risk of heart disease for those who do exercise. So the relative risk would be when you have the no exercise divided by the exercise, which is 3.3. So it's actually 3 times as likely to 3.3, just over 3 times as likely to get heart disease by not exercising compared to those who exercise. And yep, so well done on those papers. I hope this has helped. Bye.